Hello. So today we are going to be looking at your Maths CBA1, your Classroom Best Assessment 1, and we go to your OneNote classroom and you are going to go to the tab CBA1, which is the second from the top tab, and it's been there for ages. So this is not a new tab. I've had this open for you to have a look at for quite a while. And our 4 pieces of information, our first PDF here is something we're going to come back to. I've done out an example for you of how to fill in this PDF, and it's how we're going to pick a question or a project. The next one is how the questions are, or the project I should say, is going to be assessed. This is different to the features of quality you might have seen in some of your other CBAs, so you must read that document, and we're going to have a look at it in a minute. These 2 questions here are sample projects from other students. So this was an above expectations project, and this is an in line with expectations project. So this is a fairly ordinary project, and this is a very good project. So above expectations is a very good grade to get. And the main difference when you look in here, the main difference between these 2 projects is that in the Cheetah project, in the above expectations project, there is more algebra, there is more maths. So the key thing here is this is a mathematical investigation. You're going to pick a project where you can create variables, where you can create algebra, and you can do maths with those variables that you have picked. That is the absolute critical thing to understand. The more advanced the maths you show in this project, and the more you do algebra creatively and correctly, the higher your grade is likely to be. That is the absolute critical thing you have to understand for our CBAs in maths. They are mathematical projects. It's not about your English or the pictures that you draw necessarily. It is how high a grade is your mathematics. So if you go into the page count for the Cheetah, I think it might be 19 pages. This one I think is 28, but this is in line with expectations and this is above expectations. You don't need to write a novel in order to get a high grade. You need to show high quality maths, high quality algebra in particular. That's the key thing you need to have in mind when you are picking a project. Now the other thing I'm going to mention here at the front is, so we have the more algebra you do and the higher quality the algebra, the higher your grade is likely to be. Your project is an individual project. You're going to do it by yourself, and you're going to produce an individual report, an individual project report. So you're doing the project by yourself, you're writing your report by yourself, and the report is going to be sent to me in a Word document or a PowerPoint. Those are the 2 formats that you can use, and I don't mind which one you use. But it's individual work, it has to have lots of algebra in it, and it's going to be either a Word or a PowerPoint. And you can just take pictures of your copy and paste it into the Word or the PowerPoint. You don't have to do a lot of fancy writing or anything fancy in terms of what you do with your Word or your PowerPoint document. What is being assessed is the maths, how creatively you are able to use maths and algebra in particular. That's what you need to have clear in your head. Now, you need to read through all of these 4 pieces of PDFs, and I'm going to talk about some of them now. So we're going to start off with the features of quality. This is how I and the other maths teachers are going to assess your work. So you are being given the marking scheme for this test before you've done it. So you know exactly what you need to do in order to get a high grade in this project. This tells you exactly what you need to do in order to get a high grade. Now, let's have a look at our 4 different parts. These are effectively going to be the chapters of our report. So the first thing we have to do for our project, for our report, is defining the problem statement. So what question, what problem are we going to deal with in this project? And if we look here, we have yet to meet expectations, in line with expectations, above expectations, and exceptional. And those are the 4 different grades that we can get for our project. And if you read down through these, you will see the main thing, 2 things. One, if I have to give you individual help, your grade drops down to the lowest possible grade very, very quickly. If I give you any individual assistance, you are going to end up with yet to meet expectations, unless you end up doing lots of very good creative work that could bring you back up to in line with expectations. But unless I see that you aren't going to succeed at all with your project, I amn't going to give you individual feedback. I'm not going to answer individual questions, because it massively reduces your mark. The whole point of this project is for you to be working independently. So you must show independence and that you're able to drive and figure out your own problems. Now, let's start off with defining our problem. An exceptional student poses a concise problem statement and clarifies and simplifies the problem by making justified assumptions where appropriate. Now, the English of that is horrible as far as I'm concerned. But let's see if we can break it down. Poses a concise problem statement. So you write a brief and clear problem that you are going to solve. And clarifies and simplifies the problem by making justified assumptions. You state exactly what you're going to do, how you're going to do it, and how you're going to simplify the problem so that you can use the maths that you already know to solve it. Because there's lots of fancy questions we could ask that would require really complicated maths. But we could say, well, we're only going to do a simplified version of this question because I don't know enough maths to do the really advanced versions of it. If lots of problems that you would come across, you might want to use functions analysis or calculus or lots of fancy bits of maths that you can Google and have a look at. But what we need to do is be able to say, well, how can I look at my problem with the algebra that I already know? So if we can do that by ourselves with no assistance, we're getting up high in our grade. If I end up giving a project to someone and telling them how it is they need to break it down into manageable bits of maths, then we're right down at the bottom with yet to meet expectations. And you can see that this pattern continues for the rest of this document. Now, in terms of giving feedback, the English in this document is quite complicated. If there are words in this document that do not make sense to you, you are to email me and tell me that, and I can do another video for everyone where I clarify some of the language, where I explain what some of the words mean. But part of your homework for tonight is going to be reading this and getting very clear in your head about what's required of you in order to get the highest grade possible. And if there's words that don't make sense to you after you've tried to figure it out yourself, email me and I will do another video explaining this document further. But the first thing everyone needs to do is try and read through it and get their head around it as best as they can themselves. So that's our first job. Now, that's our features of quality. The next thing we want to have a look at is evaluating a proposed question. So this is the first document, the document on the left in your OneNote, and I have brought it up with some writing here. So define the problem statement. So we'll remember this is our first job that we have to do. This will be our first title in our report. So write down an area or topic of interest from your studies or the world around you for an investigation. So this is a slightly whimsical example, but it's to give you a notion of how you can take a basic question and find maths in it. So I'm not saying this is an ideal question. This is just an example to try and get you thinking about how you could get maths into a problem. So if I decided I wanted the best coffee mug, that's what I'm interested in. So how am I going to pose a problem statement for investigation based on my area or topic of interest? So what do I mean by my best coffee mug? Well, how would I turn that into a maths type question? Well, how would I have the least materials? How would I use the least materials, the least clay and so on to make the mug, but have the most coffee that I would be able to drink. And what assumption am I going to make? I measured the largest coffee mug that I have in my house, and I found that it was about 10 centimeters wide and a little over 10 centimeters tall. So I've said this is the biggest coffee mug that I am going to want to have. This is my restriction on how large my cup is going to be, because obviously if I had a giant cup I could have loads of coffee, but it starts to become impractical. So if this is my largest cup size, what is the maximum volume of coffee that I'm going to be able to get with this width and this height? So that's my problem with a little bit more mathematical language put into it. Now, identifying strategies and translating a problem to mathematics, I need to take this Englishy type question and I need to see what variables am I going to have, what letters, what algebra am I going to be able to apply. And again, this is where the marks is. I have to be showing variables, I have to be putting letters, I have to be putting algebra into practice in order to get a good grade. So what variables have I got? Well, I've got the width of my mug, and I've got the height of my mug, and I have the surface area and the volume of my mug. And if I think about my problem carefully, I want to have the least amount of materials used. Well, that's going to be effectively the surface area of the mug. How big an area is the surface of my mug? That tells me effectively how much clay I'm going to use to make the mug. And then the volume inside of that shape is going to give me how much coffee I'm going to have. So if I had a small surface area but a lot of volume, that's really what I'm looking for. So I want to find the surface area and the volume of different shaped mugs and see which one has the smallest surface area to the largest volume, and that's going to tell me what my best mug shape is. Because if I have a small surface area, I've used a small amount of material. If I have a big volume, I have lots of coffee, and that's what I like. So I have limited myself at the moment anyway to a coffee mug that could be a cube, a rectangular box, a cylinder, which would be a normal one, a sphere, or a pyramid shaped coffee mug. And I'm going to look at my formulas that I know in my log tables or online, and I'm going to find the volume and the surface area of these different shapes. So where will I find resources? I'm going to find my lots of stuff on Google. I'm going to use my textbook. I'm going to use the stuff in my cupboard, the cups in my cupboard, and a ruler in order to do some measuring. So that is part of my form filled in. And if I go down to here, engaging with the mathematics of the problem, I have note the areas of mathematics that might be used during my investigation. Well, I'm going to be using the surface area and the volume formulas for all of my different shaped mugs. List the mathematical representations that might be used during your investigation. Well, I'm going to have lots of different types of shape, so I'm going to draw tables. I'm going to draw graphs to see if I can spot patterns in what shapes are best for getting me my most coffee for the least surface area. I'm going to use diagrams to keep track of what the shapes are going to be like and what variables I've got. And I'm going to be using algebra as much as I can to maximize my marks. And I know that when I'm interpreting and reporting, I'm going to be using Word documents in order to keep track of everything. In terms of getting an exceptional grade, what I want to do is, once I have used my surface area formulas for this problem, I might say, well, does this work for larger shapes? Would it work if I wanted to move loads and loads of water around or loads and loads of oil around, and see whether I would be able to generalize the maths that I had used for solving my cup problem, my mug problem, and see if I could get that to work in a broader context. Now, the last thing to point out again is that you need to read the projects that have been given to you and look for how well structured, particularly the above expectations one was. And that's what you need to be doing at the moment.